Hello, everyone, and thank you for joining us, and welcome to this presentation, which is part of an ongoing Goose webinar series about sustained ocean observing. My name is Albert Fisher. I'm director of the Global Ocean Observing System Office, headquartered here at the Intergovernmental Oceanographic Commission of UNESCO in Paris. So for the next hour, we'll start with an approximately 30-minute presentation by Anna Lara-Lopez and Pete Strutton about using online learning to increase the profile of marine observing systems. Anna works for the Australian Integrated Marine Observing System, IMOS, at the University of Tasmania, and Pete is faculty at the University of Tasmania. So after the presentation, we'll conduct a question and answer session using the question window, which is already open on your screen. So please go ahead and ask questions during the presentation if you'd like to. Please use the send to all button so that everybody can see the whole queue of questions. And I'll be moderating and selecting the questions, asking the questions verbally. The session is being recorded, and a link to the recording will be posted on the Goose webpage as well as on our YouTube channel, where you can find all the old webinars. And now I'd like to turn it over to Anna for the presentation. Go ahead.
Thanks, Albert. Hello, everyone. Thank you for being here. So I'm going to be talking about the use of online tools for learning and to increase the profile of marine observing systems. And in this case, I will be talking about the Australia's Integrated Marine Observing Systems. So a little bit of an overview of the presentation is I'm going to talk a little bit of what is IMOS, and that's basically to give a little bit of context of who we are and what we do for those people that aren't familiar with us. I will talk about how do we fit in the international context. I will also talk a little bit about open data and also about the framework for ocean observing and what this framework actually suggests and recommends with regards to education and capacity development, as well as Australia's Marine Science Plan and what they basically recommend as well in this field. Then I will talk a little bit about online learning, and then I will pass the baton to Pete, who will basically give us an overview of the marine science and data lectures that we develop with the University of Tasmania in collaboration with IMOS and also with the Australian Institute of Marine Science. So what is IMOS? IMOS is the Australia's Integrated Marine Observing System. We're a national collaborative research infrastructure. So we're national, we're actually funded by the federal government in Australia through the Department of Education and Training. We are collaborative, so while the University of Tasmania is the lead agent for IMOS, IMOS is actually an unincorporated joint venture between several different organizations that have strength in marine science. So in here you can see basically we have several different institutions, marine institutions. We have our operational agency like the Bureau of Meteorology. We have state agencies as well as several universities that actually collaborate and basically together with the University of Tasmania make IMOS a reality. And we're research infrastructure, so we basically, our mission is to collect systematic and sustained observations from our marine environment. All the observations that we take and we collect are open and available for everyone to use. So this is basically a schematic of the different platforms that we use for observing. So facilities is basically an equivalent to observing technologies or platforms. And you can see here that we have several different kinds. We have moorings, we have autonomous systems such as the Argo floats, ocean gliders, autonomous underwater vehicles. We use ships of opportunity. We also have animal tagging and tracking, ocean radars. We do not have satellites, but we actually provide some of the observations for the validation and calibration of some of the satellite missions, and we actually develop also some products that are available through the portal. So on the corner, the right-hand corner, you can see that's the URL. That's our ocean portal, and it's basically, that's our other facility, and that's the Australian Ocean Data Network, and that facility is the one that basically does all the data management. So all our observations go through the AOD, and they do all the data management, and then they provide this data to the public through the ocean portal. So the way that IMOS is structured, basically, it is integrated. It is integrated across space scale. So our technologies, the technologies that we use, are used to observe near the coast, on the continental shelf, as well as some technologies in the open ocean. But we also observe from physics to biology. So we have observations from waves, wind, temperature, surface and subsurface currents, to nutrients, particles, as well as microbes, fish, marine mammals. So it's basically trying to integrate across the different disciplines and across different observations. So all that, obviously, as I mentioned before, ends up in the Australian Ocean Data Network, and that's the window basically to our observations. And in here you can basically see the extension that we cover. It's probably a little bit bigger than that, what you see on the screen, but essentially all our observations are around Australia and in the open ocean as well. And we adhere to the FAIR system, which is basically our data and metadata is findable, accessible, interoperable, and reusable. And I'm not going to dwell on this and give more details about that, but I just added a little sort of snapshot of the paper that basically, if you are more, if you're interested in digging a little bit more about these FAIR guiding principles, you can find them in this paper. But deploying the instruments in the water and then receiving that information, putting out in the open, is not where our work stops. We also want to make sure that the observations that we collect are actually useful and are actually being used to make science, and that science has some impact and has impact into and benefits the society. So another way that we actually track that and make sure that the observations we collect are used is through these key performance indicators that you can see in this screen. So we basically track how many publications are being produced using our data, that's peer review and non-peer review reports, how many projects include our data, how many postgraduate projects include our data, and it's basically part of the strategy that we have as an observing system in Australia, that there is a need for observing, that we have the capacity and the capability to do it, and that the observations that we collect actually have an impact for the nation. So in the international context, IMOS is basically one of the GOOS regional alliances. So you can see here the map with several different regional alliances for the global ocean observing system, and we are part of that network. So, but we don't stop only in that. We also have to make sure that the platforms and facilities that we use are actually connected to international networks as well. So that way we maintain collaboration and engagement with the international community. So you can basically see our data basically flow into these networks, and you will be able to access it through them as well. So IMOS got established in around 2006, 2007. And so we've been collecting information, observations since then, and it's being, the time series are building up, and we're collecting more and more and more data. So more and more data is basically being put out, and it's available in the portal, so you can go there and have access to it. So it's a very good wealth of information that we have around Australian oceans. However, this is not the only open data in the marine environment. There are a lot of different databases that offer excuse me, free data that you can basically access, and you can do amazing science with it. And it is important that we know how to exploit this I guess advantage this wealth of information that it's basically available at our fingertips. So the framework for ocean observing, which was basically put together by the international community after the 2009 Ocean conference, basically developed a set of recommendations for ocean observing systems. And in the space of education, basically some of the recommendations that they put is basically to develop education products that will ensure that ocean and non-ocean scientists have a broad understanding of our oceans, to develop outreach products and focus on different ways to support broad capacity building. And in the context of Australia, the Australian marine community also came together to basically have put together a national marine science plan. And basically the focus of this marine science plan is to basically look at what are the challenges that we have to meet in order to fulfill the economic potential that our oceans have in a way that is sustainable. And they sort of basically put together a set of recommendations. And in the space of education, basically one of their recommendation in there is basically the need to develop marine science research training that it's more quantitative, cross-disciplinary, and that it's in line with what the workforce needs. So together with all this immense amount of data that it's available, there are tools that we could use in order to basically develop programs that can basically build the capacity for the new marine scientists to basically use that resource, that very rich resource that it's there. And one way to do it is basically through using MOOCs for massive, one sort of system similar to that, which is the massive online open courses. They basically, this type of courses uses the internet as a platform. It is open, it is free, there's no time restriction, so it's basically up to the users to do it at a self-pace. There is no place restriction, so anyone, like infinite number of people can basically use these courses. It is set up for wide dissemination, and it basically provides also the resources in there that people can basically exploit and use and adapt. So you can see in there, I just put the three biggest systems that basically deliver MOOCs and which have some agreements with some universities. And in the case of ocean MOOCs, you can find several ocean MOOCs in there. So if you want to know about marine science, you can basically have a little bit of an overview there with several MOOCs that are available. In our case, one of the things that we wanted to do is exploit that ability to basically have a wide dissemination, that it's open, that's available, that's public, and that basically provides the resources and tools in there. But one of the things, the ingredients that we wanted to add in here was basically to provide the tools to train the people to use the data that it's available there, because we have that amount of wealth of information about the oceans that it is necessary also to teach the skills for the new marine scientists on how to exploit and use that data. So there's where we basically come together to sort of build this pilot. And we started with these three different themes, and Pete is going to talk about them in a minute. But the idea was basically this is a pilot, and hopefully we can together in collaboration with other people and other universities build a library that can basically help produce these tools that other people can use. And we tried to do it in a way that was flexible enough that can be adapted to their own places, their own local regions, and so they can basically accommodate and use these resources. So now I'm going to basically pass the baton to Pete. So he will now talk about the e-lectures. He's going to give us an overview about them. So yes, Pete. I think now you're the presenter.
So I show my screen. Okay. Right. Thanks very much, Anna. So I'm here, and so we're talking about this module, set of modules that we've developed, and I'm here in the main screen for the course content. So on the sidebar here, we have the ability to navigate through all of the different parts of the course. So this is a course using IMOS data, and there are 3 modules. One's on primary productivity, so they're just down here. One's on the marine carbon cycle, and one is on ocean acidification. And I was involved in producing the content for the one on primary productivity, so I'll mostly talk about that. So when we first get into the main page for the course, there's some general introductory material. So there's a welcome video, there's some navigation about what content is in the course. There's an explanation or a short description of who the people are who are developing or delivering the content and who helped develop it. And then there's some introductory material about the IMOS Australian Ocean Data Network, which is the facility that delivers the data. There's a couple of introductory videos. There's one about what IMOS is, and then a couple of introductory videos for the Australian Ocean Data Network. So they're an overview of how to get the data, and then the labs that are associated with the course specifically show you how to get the data. Okay, so then if we go to, I'm going to choose the primary productivity module here and just show you some of the components of that. So first there's an introduction from me, and it's just a couple of minute video about what you'll learn in this part of the course. And so this part is about primary productivity in the oceans. There's a fairly basic university level lecture about what photosynthesis in the oceans is, you know, something very brief about types of phytoplankton and how we make measurements in the ocean. So there's 3 individual videos here, and each of them is about 10 to 12 minutes long, so it adds up to be about the length of a regular, you know, university lecture. So there's 2 main things that we want to achieve in this module and the others as well. Want to explain something about the ocean, so choose a topic that is relatively self-contained and of interest to basically sort of university level education level. And we want to highlight the use of ocean data, and we want to highlight the use of several types of ocean data if we can. So we have the lectures here, and so I'll just click on one of those. And so what you'll see here is, you know, essentially a PowerPoint screen. If you click play, it goes through the slides, and I'm giving the narration to the slides. This one goes for almost 12 minutes. You know, for non-English speakers or people who can't understand my accent very well, you can get a transcript of the lecture. And you can also get the lecture slides as a PDF, and you can contact Anna if you would like the lecture slides in PowerPoint format so that you could modify them yourself. After you've looked at the lectures, there is a self-evaluation. So there's a quiz or an exercise there. Some users might just be interested in the lecture material. Some users might just be interested in the lab material, and each of them have a quiz associated with them so you can test your knowledge. Okay, so then I'll just move on to the primary productivity data lab. So you'll see there's the lab and then the exercise that I was just talking about and the answers to the exercise. So we'll click on the primary productivity lab. So there's some introduction here about the logistics of how to do the lab. So this particular lab is provided in MATLAB and in R format. So I'm more familiar with MATLAB, so I developed some of the code in MATLAB, but then Eduardo, who was helping to develop the material, also translated it into R. So you can run it in R, and if you're an Australian user, you can also run it on the Marine Cloud, and I think Anna's going to speak briefly about that after I'm done here. So there are the resources or the code to do all of this analysis in MATLAB and in R. And then we get into the sort of the core of the lab. So there's a overarching goal. So we're going to use IMOS data. We're going to use several types of data, and we're trying to reinforce some of the material that was in the lectures. So the lectures had some basic information about photosynthesis in the ocean, but also talked about the seasonal cycle of productivity in the ocean, and that's the main concept that we want to address with these data. This is sort of like a regular class lab where there's instructions about what to do. The data are all from a place called Port Hacking. So this is the southeastern coast of Australia here. This is the city of Sydney here, and Port Hacking is just a little bit to the south of Sydney. It's a place where ocean observations have been collected for a long time. So we're going to combine satellite observations of the sort of the broader area with mooring observations at that location, and also ship data from regular visits to the site. So the first thing we do is guide the students through how to get satellite data. So they go to the Australian Ocean Data Network portal. We show them step by step how to go through and get the data, but then we also provide the data that they would get from these steps as a netcdf file. We provide the MATLAB code to process those data. After they've obtained the data and processed it, they'll come up with an average seasonal cycle of what chlorophyll looks like and what net primary productivity looks like in the vicinity of that Port Hacking site. And then they can also plot satellite images so this is the site there in the middle of those images. Then we move on to getting the mooring data, and so we step through how to get the mooring data from the data portal. And then finally we give them some primary productivity data that was collected from a ship that went out and visited the site. And then we provide a time series of productivity data. And then ultimately they're bringing together these sets of data, the satellite observations that they've turned into a time series, and they're also using for the broader context, the mooring data that they're using to look at the physical changes that happen through the seasons. So we're trying to look at the seasonal cycle of mixing and stratification and how that's related to variability in productivity. And then they're using the shipboard data to, they're doing things like depth integration to come up with a total primary productivity number that they can compare with the satellite-derived observations. Okay, and then after we've done the primary productivity lab, there's essentially a quiz test, and then there's in final remarks there's a short video, and that's just an interview with me describing how I use ocean observations in my day-to-day work. And the other two labs follow a similar format. So the second one is on the marine carbon cycle. That's focused on the Southern Ocean time series mooring in that's maintained by IMOS south of Tasmania in the Southern Ocean. And then the ocean acidification module is focused on the tropical ocean, and that's produced by researchers from the Australian Institute of Marine Science. And they each of them have a similar format. The ocean carbon lab is in MATLAB and Python, and the acidification lab is in R. And then I just finally wanted to highlight there's a forum and a survey at the end that can be used for providing feedback to us, and we'd like to highlight the importance of that. We're very interested in receiving feedback. So now I think I will hand back to Anna. So I think I do this, stop showing screen. Can you take over now, Anna?
I think so.
Sorry, hang on, change presenter. Yeah, okay.
Yeah, okay. All right. I think, can you see my screen?
Yeah.
All right. So the idea basically here is, as Pete said, the some of the lectures are have 2 different languages, coding languages. MATLAB is one of them, but we also provided an open source one, which is R, or either R or Python, and that's basically to make it available to as many people as we can. So as Pete said, if you are a teacher, there is a way to basically get these lectures in PowerPoint and in an easier way, rather than having to go through all the system in order to get these tools and these resources. So you basically, after registering, you can send me an email and I will change your enrollment to teachers, and then you basically will have access to this part of the system which says only for teachers, and basically you can go in there and get the training material in a zip file. So it's a very easy way to get it. You can get the video lectures if you want them, or just the PowerPoint presentations without the narration. So you can basically adapt. You can get the transcripts as well for all the PowerPoint presentations, and all the laboratory material, which includes the data files as well as the codes. So the idea behind doing it in different environments as well, as Pete said, one is basically set in near the city of Sydney, which is around temperate region. The ocean acidification, we basically use information that it's in the Great Barrier Reef around the Heron Island region, and then the carbon cycle is in the Southern Ocean, so we have a subantarctic sort of environment in there, and that was one of the ideas, is basically to cover as many different environments as we could, basically to make it, broad and not just focus into one single region. And the codes you can basically use and modify to suit your needs. And well, there's data files obviously from the regions I just mentioned as well included if you want to test it, and then you can basically use your own regions data as well. And the lectures themselves, the PowerPoint presentations, are broad enough that can be basically used for anywhere really. Now, in the case of for Australians, the laboratories cannot be run in that system that Pete just mentioned, because you need to run different programs. So you need to either run MATLAB or run R or Python. So in this case, we use Jupyter Notebooks for Python. So you will need to basically get out of the system with the data and the codes and basically do the lab exercise outside that system that Pete showed. So you will need to install in your computer either Jupyter Notebooks or R or MATLAB, have all those programs installed in your computer in order to be able to run these laboratory exercises. However, for the Australian region, there is an alternative way, and it's basically using a cloud, the marine cloud. So that's a system that's being used, one for storing marine imagery and running models and all that kind of thing. So in this marine cloud, we put all the information as well, including the presentations. You can find them in there. You just need your credentials for Australian access. And basically, you launch a virtual desktop, and all those programs are already in that cloud, so you don't need to install anything in your computer. You can basically run your labs, do all the things that you require in several different days. I think you can basically have that desktop for 14 days before it goes back to the cloud. But then you can basically go back to it and pick it up where you left. So it's another, I guess it's an advantage as well in with respect to the Australian community, but that can be exploited. Is another infrastructure that we have, and that it will be important to use. and to teach also the train the students to be able to use and basically show them that this resource exists. So in here you can basically, this is the marine cloud, and you can see that notebook, Jupyter notebook is there, as well as our studio. So they're installed. There's no MATLAB, but you can find the lab codes in here and the presentations in this system. Now, we're also been sort of checking how many registrations we've been having and the statistics and all this kind of thing, and see how we're doing. So we basically launched the first one at the end of November. And we have one of the things that I guess you start learning once you get into this into this system of online learning is that that you need the communication is one of the most important things. And so you can see basically the bumps in there, and it's basically when it's recently launched, then people start paying attention, and then it just goes down because basically the information is not out there all the time, so people are aware. So there's little bumps when it comes out in newsletters, or when there is a reminder, etc. So that's something that we basically want to ask the community to spread the word, basically, to because there's resources in there that they can be using, you know, for marine science. And so far we have around 300 people register. And basically, we're just taking different statistics of, you know, what's the mean age, the use, what's the background of the different users, and where did they hear about it, to see which methods we can target better to get that information out. And I guess the idea with this is basically foster the collaboration, so we can basically build on other, like try to develop more of these as a library that can be accessible for different fields in marine science, and that can be used as a resource for capacity building in other places as well, and a way also for outreach to people. So with that, I think I'll leave it there, and if there are any questions, please let us know.
Thank you very much, Anna and Pete, for that presentation, and for exposing this great tool to a different audience. So the question box is open. I see my colleague Claudia Delgado, who runs the Ocean Teacher Global Academy, has started asking a number of questions, but I encourage all of the audience to ask some questions to add to ours. So let me start with actually two of Claudia's questions, which are a little specific. She's curious about what learning management system you're using, what is the course running on, and what copyright license do you use? You mentioned that teachers can download quite a lot of the material to use it for their own purposes. So what copyright do you put on the material?
So the licensing that we put on the material is Creative Commons by acknowledgement, basically. And we're running in a system that is in the University of Tasmania. So it's a platform that basically has two different modes. One is for open access, which is the one that we use, and the other one is for internal. So not that people in here are aware, but this is probably the second or third MOOC that the University of Tasmania uses in this system. The first one was on dementia, and that was basically that was a test, and it was a really successful one in using this system. So so we decided, because they're already paying all this amount of money to have this system, to basically use that resource. I mean, there are other, as I did in my presentation, there's other systems like Coursera or edX that also provide, you know, a platform to put this type of online learning materials. The problem is the cost is quite high. So for us, basically, in this pilot, we wanted to use what the resources that the university provides, and we made sure that the license was open enough so people can basically use that information.
Okay, thanks. I was actually quite curious. Towards the end, you started showing some statistics about the use of the MOOC. You said around 300 some people have been using it. I saw in the statistics the main audience seemed to be researchers, students, and teachers in kind of descending order. Is that who you targeted originally with the MOOC?
Yes. So I guess the idea first started with some people basically saying, hey, do you have any material I can use for teaching? And we really didn't have any material other teachers could use that used IMOS. And then some other researchers that are engaged with us were saying, oh, I have developed this material, can we put it somewhere? So our primary was basically teachers, but then with this system, because it allows you to basically also provide the material in a way that can be used as self-learning as well, then we thought, well, we can develop the material. You can either use it for your teaching and adapt it, or you can use it for self-learning, so students can have access to it as well as teachers.
And go ahead.
Yeah, it was a two-pronged approach that we basically wanted to have.
Right. And another thing I noticed was that you looked at how people had discovered the course, and I saw that email, social media, and colleague friend were the top 3 categories. Again, is that what you expected? Is that how you're pushing things out?
Yes, mostly through, I guess, through the different organizations I wanted to push that through. Social media, it's been really good, but the problem is there's so many posts and all that kind of thing that you need to sort of keep it in a cycle to keep people aware of it. And so you have to keep bothering people to please put another post about this. So we're trying to use several different networks basically to get this information out. So for example, we basically contacted the Australian Marine Science Association and told them, can you put it in your newsletter, and then you will see a little bump. And then I asked the New Zealand Ocean Acidification Network to please put it in the newsletter, and they'll put it in the newsletter. The Goose also, Goose put it in their website, and we saw another bump in there. So that's so it's basically trying to keep pace with trying to keep advertising to basically get people to pay attention that there's these resources. So I guess only one is not as effective, but you have to use several different ways to get the news out and in trying to attract attention, I guess, to these.
And so, as you reminded us at the beginning, IMOS is a research infrastructure, so it makes sense that you've targeted this research audience. Has there been any thought to developing modules for perhaps a more operational user base? You do have, I know you do have a forum for operational oceanography where you're starting to explore the use of IMOS in operational forecast systems for industry, et cetera. Has been thought about developing modules in that direction?
Not at this stage, no. No. So I guess one of the ideas in here is IMOS is it's research infrastructure, but we are also funded through the education department. And one of the things where we haven't actually been playing that strong, we are quite strong in the operational side of things. We have the Bureau being part of our collaborators and the joint venture, and we have the Forum for Operational Oceanography. In the case of modeling, for example, we have the Australian Coastal and Ocean Modeling and Observations Workshop that happens biannually, sort of in they interchange years with the forum, but we didn't really have any footprint in education except if the university that collaborates with us decided to create some sort of coursework, which we have in some instances. So the Sydney Institute of Marine Science does have a course, and they're really involved with IMOS, and they sort of are using IMOS in their classes. But it's at that university level. So we wanted to sort of start creating material and resources that other universities could use around Australia, and also see if with this we can foster that collaboration and basically start developing in other fields as well, like in the physical oceanography or something in the biological oceanography, that sort of thing.
So I have a question from another colleague of mine, Peter Peterson's, about the URL. I wonder if you could flip back in your presentation just to show the URL for access to that open course if it's in there. And while I'm on that, I'm going to ask you a few more questions about the students. So another question from the audience is, do you have any statistics on the completion rate and the dropout rate of those students that have engaged in the course?
No. So completion rates, we have so I guess that's one of the disadvantages of this system of open systems like MOOCs, like completion rates, because it's at their self-paced, and they will come and go and maybe not complete in sort of a short period of time. It's really hard to track. We do have actually we can track it, but at this stage we have a very low completion rate, and one of the reasons is some people are actually just interested in the only in the PowerPoint lectures. So I have people that just wanted to know the basics. That's it. They don't want to deal with codes. They don't want to deal with the labs or data or anything. They just want to know the basics. And then I have other people that just want the labs, and because the laboratory, basically you cannot run it in that system, but in your computer, then it's really hard to track then what the completion rate is in there. And that's what we basically decided to put a survey in there, so in the hope that people are going to get back to the system and tell us and give us some feedback on, you know, what they think of the courses, and if they have any suggestions to improve it.
Okay, and then again, a little bit more about that. So what level of follow-up, and thanks for, I guess the URL is there on screen. So you type once you're at that URL. And then how do you find the courses themselves?
Huh?
And then how do you find the particular of those 3 modules?
So you basically have to go to this particular URL, the one at the top.
Okay.
And in there, you basically have to register, and then you have access. Once you register, you have access to all the modules. So the only requirement in this case is basically registration. That's all. And then you basically have access to all that. If you want access, easy access, because you still have the access to all the presentations and everything, and you can download the PDFs if you want. But if you want the PowerPoint presentations, you just need to tell me, just send me an email, and then I'll give you access to the other part that I just showed, which is the only for teachers. And that just makes it easier because it's in a zip file and you can get the PowerPoints in there.
So maybe a question for Pete, who contributed some of the lectures to the course. What level of follow-up is needed to interact with the students, or is it just the students on their own once you've created the course material?
Well, personally, so I'm going to use this in a couple of weeks in a 3rd year university class that we're doing right now, and that course is called Ocean Observations. And so I'd also consider using it in a 2nd year class of mine. So if I were to use it, I wouldn't just give it to the students to me personally, wouldn't give it to them to go and complete at their own pace. I would sort of run through that material in a 2 or 3 hour data analysis lab slot, and so walk them through. I have other classes where I do labs like that, where we spend 2 to 3 hours working on data sets and doing a short write-up and answering some questions along the way. So yeah, I guess there's a couple different ways that you could run it. Personally, when I'm going to use it, I'm going to do it sort of guiding the students through it.
Okay, and so that works for students of yours in the University of Tasmania, but the purpose of doing a MOOC is to enlarge that audience. So how do you think students, how self-driven do they need to be to get as much out of it as being in your course at the University of Tasmania?
Yeah, so we've tried to have a level of explanation in there that's going to take the students through sort of step by step, so that we're not leaving them up to their own devices too much. The target was sort of upper level undergraduates or maybe even lower level graduate students. It would be targeted at about that sort of level. The lectures would take roughly an hour for each module to look at, and then doing the data analysis. Doing it by yourself, I think, would probably take more than a couple of hours to step through each of the data downloads and data analysis parts. But yeah, I think it's the kind of thing that's easily achievable by an undergraduate student.
So we have a question from Tim Altman, the director of IMOS. Why did you choose these 3 topics? What's next?
Well, we chose those 3 topics. One Pete was happy to jump into this, but the other thing is, for example, ocean acidification, interest was actually dropping a little bit, particularly when it comes from government not funding or not paying attention to that. So I thought raising that profile would be important. Carbon cycle, not many people actually use this, so it's somehow obscure. So it's basically trying to bring this up to the audience and saying, look, there's these very interesting things, and the carbon is actually quite important because it has to do with the CO2 and uptake of carbon in the oceans and all that. So they're important themes, and it's just basically raising the profile of them to the audience, to the students, to the teachers. So they can talk more about these themes. However, they're not the only ones that I would like them to be there. I'd like to develop also in the physics, which are very active already, or on the biological side. But these ones are the ones that I thought needed a little bit more profile to bring out to audiences, basically.
And so what is next? Are there new modules planned?
I'm hoping so. I think I'm sort of in talks at the moment for a module in zooplankton. So hopefully that will be next. But I think one of the things that we want to encourage with this is not that these lectures are done through us and through this system. The idea is to basically foster other universities to take this on as well and develop their own modules, and then basically create a library that it's available, that gives the resources to all other universities and all other places, but you can use those resources to adapt to your own needs. So the idea is not that we will develop everything and have everything and put it in this system through the University of Tasmania, but rather getting the other sort of universities interested in actually developing their own courses and participating in this. Yeah.
Okay, and
that's
to
what
that,
I'm hoping.
Just on that note, my colleague Peter Petersons has actually already added you to the Ocean Data and Information System catalog under training materials, this material, so you can look at what other training materials there are. That's a start towards what you're talking about, is having material from around the world available. Let me ask Pete, how long did it take? Obviously, some of the material that you developed for the course was already developed for in-person teaching. How much time and effort does it take in addition to that to create the module for this online system?
Well, me personally, it was so working with Anna and Eduardo and the rest of the team. It was a couple of sort of half-day sessions where we sort of I had to, a lot of the lecture material I already had. I had to spend quite a small amount of time actually just sort of delivering the lecture and breaking it up into those 3 smaller parts. Developing the lab was a couple of sessions of a few hours, and But Eduardo, who was working with us on the project, did a lot of the getting it into shape to put on the internet. He did all the translation of my MATLAB code. So the coding part took me maybe an hour or two. Writing the scripts, Eduardo translated it into R. I don't know if Anna can say sort of roughly how many hours Eduardo put into the project, but for me personally, it was probably 3 sessions of a couple of hours working with Anna and Eduardo.
It was a substantial amount of work, I guess, in terms of for Eduardo and me in terms of you need to edit the videos, you need to edit the presentations and sort of make sure that all the copyrights are there, that people are getting acknowledged for their contributions and all this kind of thing. The translation from one language to the other, the coding languages, I mean, making sure that the system works. All these, this project was developed throughout last year, basically, and we started around April, and we launched the first one at the end of November. It wasn't full time, obviously, but yeah.
And was there I maybe missed that in the talk, was there any specific funding for developing a MOOC, or is that just part of IMOS's outreach and communications?
No, there was a specific funding. So we basically put a bid for a grant through the University of Tasmania for teaching and developing grant, and with that grant, basically, it allows us to get this material and basically to hire also Eduardo to help us with this work. So it was through an external grant from university to get this together.
Okay, thanks. And one of the things that both GOOS and IMOS are trying to encourage is the exchange between regional approaches to observing systems, the exchange between different regions, and having more developed systems like Australia is helping out nearby systems. You mentioned, Anna, in your talk, the possibility of this being used in a capacity development context. Do you think that it has been used? Do you have knowledge that it has been used in that context? And if not, how would you think the content might have to be adapted to be most useful in a capacity development context?
We haven't. I know there's several other countries that are using this material, and for capacity development, I guess it will need to be possibly translated to other languages as well to help out in that respect. The codes you don't need to, but I guess probably the introductory material and all that might need to, if you want that to sort of to be spread to other regions, and particularly on developing countries, perhaps sort of a translation will help. Transcripts help, so we have some examples of people that are using it that are Spanish speakers and that have sometimes some issues with the accent, and not not Pete's accent. For example, we have Paula, who is actually a Spanish speaking person. Her accent in English is difficult, but the transcripts actually that we provide in there help as well. So it has helped many of the users whose English is not their first language to basically utilize this material. But I guess in that respect, perhaps having this available in other languages might actually help pick up that capacity development.
The content of the course that might be in the future modules that would be more oriented towards delivery for Pacific Islands, for example?
Refocus to what? Sorry?
For example, for the topics of greatest interest to the Pacific Islands.
Yeah, I mean, that could be a possibility. I guess one of the things that we try to do in this respect is, I mean, if there's data available, it can perhaps be adapted. That will be something that needs to be. I mean, I didn't develop this material myself. I have the experts like Pete. So in that respect, it's probably just involving the experts and see which ways we can basically adapt these for better targeted, I guess, capacity development.
On the lab work that uses MATLAB or R and Python and some of the other tools, do you point to, again, thinking about the capacity development context, but this could apply in Australia as well as to other regions. Do you point to resources for students who might not be familiar, might not be up to speed with using the codes? Are there MOOC? There must be MOOC resources. So do you specifically point students out that direction if they have difficulty engaging in the material?
No, we actually haven't point them out to other. You mean other platforms where they could be? They could. There is. I mean, we point some of the links to. If you need help with R, go to this link for more information. In the case of Python, we do the same. We point them like to the help page of Jupyter Notebook. So there is in the lab, in the instructions, you can basically read through there and say, okay, to do this, you have to, if you want more information, go here, and you just link, and it's hyperlink to that particular site. So they have the ability to basically navigate to those sites and get the help they need from those particular platforms. We don't do that with MATLAB, but we do that with R and with Python. Okay.
Yeah, and I imagine that for students coming with many different backgrounds, that could be really useful to get them up to speed to be able to engage in the course. You talked about the Australian cloud system that provides integrated access to some of these tools to do the labs. Is there any program that allows foreigners to use that cloud in a kind of capacity development context?
I'm not entirely sure. Unfortunately, I don't know. There could be, but I'm not sure if there is. So I know the cloud is Australian, and you will need an Australian access number to be able to get there. You need to be affiliated with an Australian institution in order to be able to use that cloud. I'm not entirely sure if there is one that will exist in that respect. One of the things that I like to do is if we can put this material through, say, the Global Ocean Teachers Academy, maybe through there, I don't know, if something can be worked out. I'm not sure. But the programs that we use, and that's the reason why we did the translation to R and to Jupyter, is that you can basically, it's open access, so you can put them in your computer anyway. So they can be used anywhere in the world. So and that was one of the reasons we didn't just want to put MATLAB in there where you need a license, but have open source coding programs that everyone can use. The cloud only offers a convenience where you don't need to basically install it in your computer, but that's basically it. So it's not a special license.
Right. Well, and my colleague Claudia has reaffirmed that she will engage with you on getting this material into the Ocean Teacher Global Academy. Let me close out maybe by asking both of you a question about what you think the lessons you've learned from doing this MOOC have been, both in the context of what it brings to IMOS and just the amount of effort that you had to put in to make it a success with the students. I'll start with you, Anna, and then I'll go with you, Pete. Anna?
The lessons learned is that basically this constant, you sort of make a plan on how to build these modules and which one is the best way to do it, and normally you leave the communications at the end. And I have been grappling with trying to basically spread the word that this exists, and it's a constant sort of battle, and it needs constant attention in that respect. I'm sort of like making sure, okay, just get it in here and trying to get it in there and contact people around and getting them to put this information there. And it's just that I was warned by, for example, the people that developed the dementia MOOC, and they have been very successful. And that's one theme that will basically attract a lot of different people from all different backgrounds, not necessarily only marine scientists. So this group will be a much smaller one, and just trying to get that's one of my lessons, is like always dedicate a good amount of time for the communications and put it first in there, because it is possibly not possibly, it is one of the most essential ingredients in this. So over to you, Pete.
Thanks for that.
Yeah, I think two things. It was a lot of work for Anna and Eduardo. It wasn't so much work for me, but I would say that the step from taking something that some of this, the lab material I developed from scratch, but I would say that if you were to use a lab that you already had sitting around and that you developed to students, I think the step from taking it to ready for students that you interact with in person to getting it onto the into a format like this, it does take probably more work than you would think to get it ready to stand by itself where you're not there to explain it. And also the other thing I think I learned is that it took way more time than I thought to clear all the copyright issues of all the material that we presented. And it's not just for this, it's for, you know, I heard it from other people who are adapting classes that they already deliver at the university and taking it into a broader context, I guess maybe we're not aware of how much copyright we're infringing when we give lectures every day, and sort of sanitizing those PowerPoint slides, that takes a long time, and there's a lot of, you know, really good material that you just sort of have to chuck out and redo.
All right, thank you to you both. And
one of the things, sorry, Albert, one of the things I forgot to mention for IMOS in your question, for IMOS, I guess one of the things that we're looking is get IMOS into as many universities as we can, because we have an expensive infrastructure that's there where the data is available to everyone and we want people to use it. So to take advantage of what's there.
Okay, and just on that point, I'll just, Tim emphasized, and a question that a response that you made earlier, which is that the research community involved in IMOS can't do this alone, and we need the expertise of the teaching and learning community to do these MOOCs well. Anyways, that brings us to the end of the hour, slightly over, in fact, so thank you to the audience. Congratulations to you both from audience members' comments in the question box and from myself. Thank you very much for taking the time to share this course with us, and I hope that by sharing it with us, it gets an even bigger audience for the future. Thank you very much.
Thank you.
Thank you.
All right, goodbye to you both. Goodbye to everyone. Thank you.